All right, the next student asked for, one to do with double angles. And again, that's not something that I've covered since last year. So I just don't have any like problems or anything like, created. I don't even remember all the formulas for like double angles of cosine, so I just kind of did a quick look and I was like, all right, let me just kind of do a problem, which is very similar to what we did here. So, when we get into solving trigonometric equations, a lot of times if we just have one isolated double angle, there's ways to save it without using the double angle formula, which is a lot easier. However, in this case, you can see we have sine of 2 theta plus sine of theta. Well, we can't combine them. They're not the same trigonometric functions. This one's of 2 theta, this one's of theta. Oh, well, thank you very much. You caught my eye, polynomials algebra. Find the area of a cylinder. I do appreciate it. I will do my best to make sure I can add that in there. As far as cylinder, I like that. It's been a while. So if you do have one though, like actually a cylinder you want me to cover, I will do that. Otherwise, I'll just explain the concept and then give you the form at the end. So thank you so much for the super chat. I really do appreciate it. I don't think I missed anything else though, did I? Hopefully not. All right, definitely see a lot of you guys coming into the chat, which is awesome. Thank you guys so much. I would, again, highly recommend though. I do apologize, guys. I'm just not going to be able to get to all the questions that come in on a chat. So, if you do have that opportunity to ask those questions ahead of time, I always try to make sure that I post the questions or for the community chat and everything for you guys to post your questions below ahead of time. So just try to make sure if you have the time to go ahead and do that. So therefore I can make sure that you are on the list. All right, so in this problem, we need to use the double angle formula. Otherwise, there's a little bit easier way to do it when it's just one isolated. But let's not worry about that. For right now, let's use a double angle. Sine of 2 theta is going to be 2 sine theta cosine theta plus sine of theta. Now, again, we're going to be finding all the solutions. And again, I made this problem up, but I believe this one works. So here, again, you can factor out the sine of theta. That's going to leave you with a 2 cosine of theta plus 1 equals 0. Yeah, this one works. All right, perfect. So now we can use the zero product property just like we did before. So sine of theta equals 0. And then 2 cosine of theta plus 1 equals 0. So therefore, cosine of theta, subtract the 1, divide by 2 equals negative 1/2. Okay, so now we need to identify again by the unit circle where all of these points exist. Now, this one's a little bit different than the last one, just because of the fact that we're just not looking for all the solutions between 0 and 2 pi. We're looking for all the solutions. That means infinite repetitions going around the unit circle. So the first one, when is sine of theta equal to 0? Well, we already talked about that one last one. That's at 0 and pi. But again, like 0, then pi, then we could add pi. We could add pi, and we could add pi infinite many times. We could also go in the opposite direction, right? So we could have negative pi, negative 2 pi, and so on and so forth. So the way that we look at this, and actually, what do I explain? How would I teach that? Oh, I guess I would say find all of the solutions between 0 and 2 pi first. That's what I used to teach. Okay, so I'd say let's do the solutions between 0 and 2 pi first. So between 0 and 2 pi, that's going to be 0 and pi. Now, that's for the other one. Sorry, I'm confusing my instruction. We haven't got to this yet, so I was trying to think of, but what is the best way? But no, that's what we do for the double angles when they're isolated. We don't need to do that for this. So basically, what we need to do here is list the first solution, x equals 0. And then plus pi. Now, again, I could add pi infinite many times, right? So we're going to use a variable. Now, this is something we just taught in my class. So we're going to use the variable n. Because if n is 0, then we have a solution at 0. If n is 1, we have a solution at pi. If n is 2, we'd have a solution at 2 pi. And you can see for every interval of n, this works. Now, we really don't need to have 0 here. So we can write a final solution here of pi n. All right, the next one is, what about when cosine is equal to negative 1/2? Well, cosine is equal to negative 1/2 if you go through the unit circle for that angle and that angle. So we have these two angles. Now, these two angles are going to be x equals, let's see, that's going to be 2 pi over 3 and x equals 3 pi over 3, 4 pi over 3. I hate when that does that. Okay, so what we have here is, again, there's really no relationship. Like, you can't add pi. If you add pi to 2 pi over 3, that's going to take you over here, which would be 5 pi over 3, right? So that doesn't work. So the only time to get infinite many answers here is going to be adding 2 pi, right? And you could add 2 pi once, twice, 3 times, or either way, we're just going to add 2 pi n number of times, just kind of like in this case. So this one's going to be x equals 2 pi over 3 plus 2 pi n, and this one's going to be the exact same answer, 4 pi over 3 plus 2 pi n. So that's basically how you handle those in the difference between finding the solutions between 0 and 2 pi, and then finding the solutions between, or finding all the solutions. And again, if you have some repetitions, that's what you want to look at as far as, instead of adding 2 pi to 0 and adding 2 pi to pi, we could just say add pi to 0, and that's going to give you all those solutions as well. So that's just one of the ways to kind of cut down on the redundancy of your answers.